Okay, so we're gonna talk about parts of a wave. Okay, and so let's look at the anatomy of a wave. Anybody know what anatomy means? You ever heard that term before? Anatomy of a wave?
The basics.
The basics, what a wave's made of, good. Anybody else? Okay, so anatomy of a wave is what makes up a wave. What's it made up of, right? So we're gonna look at the parts of the waves using this transverse wave. And we watched a little video yesterday about the transverse wave. Do you remember we watched the transverse, okay? So, and it looked kind of like a rope,
Like a,
just moving back and forth, right? Yeah. Okay, so we're gonna look at the parts of the wave using a transverse wave in a rope as shown below. And the machine yesterday, it would oscillate, and it looked like the energy is traveling through, which is what it was really doing, right? Okay, so let's take a look here. So this right here, the little dashed line right here, everybody see the dashed line? That marks the equilibrium, and what do we say the equilibrium is? It's the what?
a rest.
The rest position, right? Right in here. Okay, so when the wave is right in here, that's the rest or equilibrium, because equilibrium means equal. So, and also means rest, okay? So this is the position the rope would have if there was no disturbance through it. And then once that disturbance is added, you remember the machine? It oscillated. So once the disturbance is added, the rope's going to vibrate up and down around this point right here. Okay, so it's going to go below or it's going to go above. Now what are these parts? How do you know what part's what?
Because of the rest position.
Well, so you got waves up here, waves down here, and they've got names, okay? So that's where we're going with this. Okay, so the crest of a wave is the point on the median that exhibits the maximum amount of upward displacement. In other words, it's the top of the wave, right? The crest of a wave. Anybody ever seen a movie of surfers riding waves? When they're right on the top of the wave, that's the crest of the wave, okay? So the crest, that's the top of the wave. Okay? And then you have something called the trough. And the trough is the point that exhibits the maximum amount of downward. Okay, so you have a top to each wave, and then you have which is called the crest, and then you have the bottom of each wave, and that's called the what? It's called a trough. Okay, called a trough. Anybody ever been on a farm, watch cows eat? You know what's that thing called that they eat out of? Called a trough, right? It's got a kind of like a bowl shape on it. So here's the trough, right? You fill that up with cow food, right? Okay. So you have the crest, which is up here above the equilibrium maximum amount, and then you got the trough, which is below the equilibrium, the maximum amount. Okay. So you got the crest and the trough, right? Crest here, trough here. Okay. Okay, so then you have something called the amplitude of a wave. Okay? And the amplitude of the wave is the maximum distance away from the rest or the equilibrium. See right in here? Here's the equilibrium. So from this point to this point is called the amplitude. Okay? Here's another amplitude from this point to this point. What about from here to here? What would this be called? From here to here, what do you think that'd be called?
The negative something.
Well, it'd be the amplitude as well. Okay, so you have an amplitude below and you have an amplitude above, right? Makes sense? Okay, so what are some units that could be used to measure a wave's amplitude? Let's find out here. Okay. Okay, so look right here. So the amplitude, now remember that's from the equilibrium part or the rest position where this black line is here. Same here. And it's from either from here up or from here down, right? On each one of these waves. Which one, has the most energy, you think? This one or this one? Which one do you think would have the most energy?
The small one.
Small one have more energy? Okay.
Cause it has more like, more
Mhm.
medium, faster.
Okay, so the farther away from the equilibrium of the rest position, you're gonna have, what do you say there, Michael? Which would you say would have more energy, this one or this one?
The second one. The second one?
Okay, what do you say, Terry? Which would have more energy, you think? Here's the equilibrium, that's the rest position. Which would have more energy, this one or this one?
The second one.
Okay, what do you say there, Dakota? Which would have more energy, this one or this one? It's okay to be wrong. Just what do you think? Second one, okay. Let's see if we can open up. The one on the right. The one on the right, transports more energy because it has a larger amplitude, right? So it's longer, up and down, right? The crest is longer or taller and the trough is lower. Crest is shorter, trough is lower, right? So more energy here on the right, okay? Got it? Makes sense? Makes sense? Michael? Terry? Makes sense? Okay. Okay. Okay, so let's look right here. Okay, so, we're still talking about the anatomy or what makes up a wave. So the energy that a wave transports is directly proportional to the square of the wave amplitude. Okay, and look how, look at the symbol here. So energy, and you got amplitude, and we said square, right? You know, like 2 square. What's 2 square? So what would be 2 squared? Mathematically, let's think of a math problem. Think you're in Miss Leslie's class. She says, define 2 squared. What's 2 squared?
We haven't like that yet.
It's 2 times what?
2.
Okay, what's 4 squared?
4 times 4.
4 times 4, good. Okay, so that's what this is too, amplitude squared, okay? Okay, so if you have, and this is energy versus amplitude, right? So this means that if a wave amplitude doubles, the energy is gonna quadruple, just like your 4 times 4. 4 square is 4 times 4, right? 4 and 16 is quadruple, isn't it? You understand? Okay, good. Okay, so 1 unit of amplitude is gonna yield 2 units of energy. 2 units, just like your 4 squared, is gonna be, this is quadruple this, right? And this is what? What is this right here? 4 units is gonna be what?
4 times. 4
Hmm?
times
It's gonna be more than that. It's gonna be, 60, it's gonna be 64. 64 units. $64 units. Okay? Got the idea? You're quadrupled, isn't it? Okay. Okay. Okay, let's move on here. Okay, so we talked about the crest, right? We talked about the crest, that's this right here. We talked about the trough, right? And we talked about the amplitude. The amplitude's from here to here, from the rest position to the top, the crest, or from the rest position to the trough. And so now let's talk about wavelength. Look at this symbol right here. It looks like an upside down Y to me. Okay,
Yeah.
and you'll see that symbol again. Okay, so a wavelength, and that's the mathematical symbol of it, is defined as the distance it takes a wave to complete one complete up and down motion. It's going up and down, right? Up and down, up and down, okay? So a wavelength is defined as the distance it takes a wave to complete one complete up and down motion or vibration, so, and it's called one complete wave cycle. Okay, and it can be measured in various places along the wave. Okay, so from this crest to here is the wavelength. It's how wide, Mr. Hughes, hang on a second here. Okay? Basically how wide the wave is, right? Wave length. Okay, makes sense? Okay, so what units could be used to measure the wavelength of a wave? Well, let's find out. Okay, so look right here. Okay, where's the, from the crest to the crest? Label the following wavelengths by dragging the arrow line. So who's gonna be first here? Who's gonna come up here and go from the, you're gonna, show from the crest to the crest? Michael? You wanna come up here and do this? Which one is gonna go from the crest to the crest? Where's the crest to the crest?
To the dash to.
Come up here, Joel, come up here. Come on, don't be shy, come on. I have faith in you, dude, come on, I got faith in you here. Show me where the crest is. The crest, you remember where the crest is? Is it the top of the wave or the bottom of the wave?
Top.
Huh?
Top.
Move the arrow.
You can move this.
That's the trough, dude. That's the
What?
trough.
You said move the arrow.
Move the, that should move. We wanna go to the crest up here. Where's the crest, top or bottom? There's the crest. Good job, dude. Good. Good, okay. Who's gonna come up here? Terry, you gonna come up here and do the, trough? From the trough to the trough? Don't be shy, come up here, Terry. Come on, Terry. Where's the trough at? Here's the crest. The crest is the top of the wave. How about the trough? What's the trough? You're gonna move that arrow and show me a trough. There you go. Where's the trough? Trough. Good job. Perfect. Okay. Which one of you guys gonna come up here and show me where the equilibrium is? Come up here. Show me where the equilibrium is. There you go. Oh, you're being nervous. You have to put your finger kind of strongly against the board and just move it. Good. Let's try again here. Okay, try it again. There you go. There you go. Equilibrium. No, the equilibrium. Where's the equilibrium? The rest position. There you go, right there. Good. I like that. Good job. Okay. So you see this? Here's the crest. Trough. And what's this?
Equilibrium.
The equilibrium or the rest position, right? Okay, so, you can use, you haven't used Cami, have you, Dakota? Okay. Okay, so I'm gonna ask you a question here. Now, I'm not gonna give you the answer, okay?
We gotta do it ourselves.
We'll answer these, after the video, right? You understand that? That gives the person at home time to answer as well, right? And
Can we go
turn it in.
over them when we answer them now, then we go over when the video.
We're gonna go over with the video when the video's off. You're right. Yeah, you're exactly right. Okay, so, you ready? Okay, let me show you here, Dakota. Look right here, you got two choices here. When you use this, you can either use the text and put a line, or you can use the drawing here, or you can use the shape and put like a circle, which is what most people do. They use the shape, so you could, but there's a drawing tool, and then there's a text tool, a text box tool, where you can choose your answer, okay? Got the idea? idea? Okay, which one do you think you're gonna use, the drawing tool? Okay, so you can just, choose your color, anything but red, and then you just put a little line beside it or circle it, whatever you wanna do, right? Circle the whole answer. Okay, so, here we go. Are we ready? Okay, so here's our first question here. The distance for a wave to repeat one complete vibration cycle is called a what? Is it called a wavelength or an amplitude? That's your only choices here, C or D. Can't choose A or B. The distance for a wave to repeat one complete vibration cycle, is it called the wavelength or the amplitude? Mark an answer. Terry, you got an answer? Okay, good. Dakota, you figured it out? Okay. Good job. Just don't use red. Okay. I'm ready to move on. You guys ready to move on? Everybody ready? Okay, so let's look right here. Okay, so, this kind of looks like part of the video we watched yesterday, right? Okay, so the figure below shows a snapshot of a wave. This is just a snapshot of that little video we watched. Using a movable ruler, if we use the ruler, you can measure the waves what? What are they gonna measure up here? What are they gonna measure?
The crest.
Are they gonna measure, could you measure the amplitude? Could you measure the crest height? Could you measure the wavelength, or could you measure all the above? You choose. What could you measure with this ruler here? And you can manipulate the ruler any way you need to get a measurement.
Mine
Okay?
isn't.
Could you measure the amplitude? Could you measure the crest height?
Oh, no.
Could you measure the wavelength, or could you measure all of them? Okay. Anybody need more time? Got an answer, Michael? Good, Dakota? Good, Joel? Thank you, sir. Terry, got an answer? Good. Let's move to the next one. Okay, so let's look right here. What's this black line measuring? What is this measuring from here to here? Is this measuring the wavelength or the amplitude? C or D, that's your only choice. Is it met from this line right here, from here to here, is this measuring the wavelength or the amplitude? Wavelength or the amplitude? Got an answer, C or D? Can't choose A or B. Everybody got an answer? By the way, did I tell you, you can go back and look, you don't have to guess, you can go back and look at the other, you can look at the other slides here, where we were talking about what that is right there, from there to there. Okay? Are we ready? I'm moving on. Woohoo! Okay. Here we go. The distance between between maximum displacement above and below the rest position is called above or below. Okay? Look here. Here's your. Here, I want you to see this here. Uh-oh. Mr. Hughes, what did you do that for, dude? Okay, here we go. Hang on 1 second. Let's go back here. I want you to understand what this question's asking. I want you to understand what this question's asking. Here's your rest position, right? There's your rest position. So the distance between maximum displacement, and here's your waves here. Okay, here's your rest position, right? You see that? Okay, so the distance between the maximum displacement, either above or below this line right here. What is that called? Is that called the wavelength or the amplitude? C or D, only choice. This is your rest position or equilibrium position. These are your waves. And you're going from here to here or from here to here. What's that called? That's called the wavelength of the amplitude. You don't have to guess. You can actually go back and look at where we talked about wavelength or amplitude or what it is. Especially if you're home. Go back and look. Look at the slides. Everybody there? Everybody got an answer? Anybody need more time? Okay, I'm gonna move on here. This may be, one more. Okay, the symbol for wavelength. There's only one of those symbols that we talked about up there. Is it lambda or is it beta? Which one of those symbols did you see when we talked about this video here?
We just talked
When
about.
we talked about this here. Is it called a lambda or is it called a beta? Mark your answer, A or B. Can't choose C or D. Which symbol did you see that I talked about? Don't blurt out an answer. Mark your answer. I know you know the answer, Julia. Everybody got an answer? Okay, 16. When the amplitude of a wave triples, the energy of the wave transport also triples. Oh, be careful with that one.
That was the last one.
Oh, it gets 9 times bigger.
Yep, I thought.
Remember, that's the, yeah, okay, you got it?
That was the last one.
Huh?
That was the last one.
Are you kidding me?
I don't know.
How many questions did we have there?
Like 6.
Okay, so we're actually gonna stop right there. And we'll come back to this tomorrow, okay?